All of these examples are what I call single element acids. That is, they consist of H plus and X minus, where the X minus is a single element. That is something off the periodic chart, as opposed to being a polyatomic ion. This has a great effect on the name that we're going to have to deal with here as well. So HCl, what I'll do is I'll say, well, Cl minus, and we know that the H here is going to be H plus. So we've got H plus and Cl minus. The name of this would be hydrochloric acid. Now the acid part of the name is the H plus. Now the Cl minus is the hydrochloric acid. Now hydro is not because of hydrogen out the front here. The hydro is saying that this is a single element anion. That is, it comes off the periodic chart. So those are the two ions we're dealing with this one. The next one, H2S, if I drew a picture of it, it would look like this. H, H, and S. If I look at the periodic chart, I see S has a -2 charge, because it's in group 6. And that means it's total -2, +2, so H is going to be 1 plus and 1 plus, or you already knew that. The ions we're dealing with here are H plus and S2 minus, and again the name would be hydrosulfuric acid. So the H plus is telling us it's acid, and the S2 minus is hydrosulfuric, hydro indicating that this is a single element anion that we're dealing with here, not a polyatomic ion. Alright, let's look at the next one, HBr. HBr is H and Br. Now Br is -1, and the H is going to be 1 plus, so this would be hydrobromic acid. And again, the H plus is telling you the acid, and the hydro out the front here tells you this is a single element anion. This is important because if you had something like HBrO3, the name of that is bromic acid. So you know we can't have two things that are different that have the same name. So we needed to say have a way of indicating this is a single element anion in the name by putting a hydro out the front, so that if ever you found this name, you'd know exactly what you were dealing with, which would be hydrobromic acid, HBr, and not bromic acid, HBrO3. As you can see, this one has a polyatomic ion, while this one's single element. Alright, let me get rid of this stuff, and we'll continue. Alright, the next one, HI. HI is going to be I negative because it's in group 7, and it's going to be H plus, and the name of this would be hydroiodic acid. So you can see they all end in acid for the H plus, and it's hydro, then the root name in ic, hydroiodic acid in this case. And this one, HF, F is a -1, it's in group 7, H is plus, hydrofluoric acid. Again, the H plus for the acid, F minus indicating it's a single element anion, so it's hydrofluoric acid.